To locate covered-up outlet boxes behind walls, several affordable wire finders are available. The Klein Tools ET540 non-contact voltage tester with wire tracer costs around $30. The Klein Tools VDV500 1.820 multimeter with non-contact voltage and wire tracer costs around $40. The Sperry Instruments Stinin non-contact voltage detector with wire tracer costs around $20. The Southwire Tools and Equipment 396,240 3-wire tracer costs around $25. The Fluke 901 SC insulation multimeter with wireless display costs around $100 and provides wire tracing as an optional feature. To use a wire finder, firstly, turn off the power to the circuit. Secondly, set the wire finder to the correct mode, typically wire trace. Thirdly, place the detector near the wall where you believe the outlet box is located. Fourthly, move the detector slowly along the wall until it detects the wire. Fifthly, mark the location of the wire with a pencil or marker. Sixthly, repeat steps 4.5 for each wire in the outlet box. For accuracy, firstly, use a pencil or marker to trace the path of the wires as you locate them. Secondly, keep the detector as close to the wall as possible without touching it. Thirdly, avoid moving the detector too quickly. For best results, use a wire finder with a built-in flashlight to illuminate the work area. A non-contact voltage tester, often abbreviated as NCVT, is a device used to detect the presence of voltage without making physical contact with the conductor. These testers are designed to provide a quick and safe way to determine if a wire or electrical device is energized. When the tester is placed near an energized conductor, it typically emits an audible beep, visual light, or vibration to indicate the presence of voltage. Non-contact voltage testers operate on the principle of capacitive coupling. When an energized conductor is brought near the tester, it creates an electric field. The tester detects this field and provides an indication of voltage presence. These testers are designed to detect alternating current or AC voltage. Direct current or DC voltage detection may not be possible or reliable with standard non-contact voltage testers. The sensitivity of non-contact voltage testers can vary. Some testers allow you to adjust the sensitivity to detect voltage from different distances or through various materials. The testers are used to check for live wires before working on electrical circuits, identify faulty outlets or switches, and troubleshoot electrical problems. Non-contact voltage testers enhance safety by allowing electricians and homeowners to check for voltage without directly contacting live wires. By simply holding the tester near a wire or device, the presence of voltage can be detected, reducing the risk of electric shock. Using a non-contact voltage tester is generally straightforward. Turn on the tester. Place the tip of the tester near the wire or device you want to check. Observe the indicator light, sound, or vibration to determine if voltage is present. Some testers may have additional features such as a flashlight or adjustable sensitivity settings. Always follow the manufacturer's instructions for proper usage and safety precautions. While non-contact voltage testers are useful tools, they have limitations. They may not be accurate in detecting voltage behind walls, inside metal conduits, or in shielded cables. Also, they only indicate the presence of voltage, not the voltage level or current flow. Non-contact voltage testers come in various types, including pen-style testers, wand-style testers, and clamp-on testers. The choice of tester depends on the specific application and user preference. Some testers also include additional features such as continuity testing, resistance measurement, and current measurement. Electrical safety is paramount when working with electricity. Non-contact voltage testers are an essential tool for ensuring safety, but they should not be the sole means of verifying the absence of voltage. Always use appropriate personal protective equipment, such as insulated gloves and eye protection, and follow proper lockout/tagout procedures before working on electrical circuits. Regular maintenance and calibration of non-contact voltage testers are important to ensure accurate readings. Check the battery level regularly and replace batteries as needed. Also, inspect the tester for any damage or wear that may affect its performance. A multimeter is a versatile electronic instrument used to measure voltage, current, and resistance. It combines the functions of a voltmeter, ammeter, and ohmmeter into one device. Multimeters are essential tools for electricians, technicians, and hobbyists. They are used to troubleshoot electrical circuits, diagnose electronic equipment, and verify the accuracy of electrical components. A multimeter can measure both alternating current AC and direct current DC voltage. The voltage range typically spans from millivolts to kilovolts. The multimeter can also measure AC and DC current. The current range usually spans from microamps to amps. The multimeter measures resistance in ohms. The resistance range can span from ohms to megohms. Multimeters come in two main types. Firstly, analog multimeters, which use a needle and scale to display readings, and secondly, digital multimeters DMM, which display readings on a digital screen. Digital multimeters are more accurate, easier to read, and offer additional features compared to analog multimeters. Basic multimeter functions include voltage measurement, current measurement, resistance measurement, continuity testing, and diode testing. Some multimeters also offer advanced features such as capacitance measurement, frequency measurement, temperature measurement, and data logging. To measure voltage, firstly, select the appropriate voltage range on the multimeter. Secondly, connect the multimeter probes to the circuit in parallel. Thirdly, read the voltage value displayed in the multimeter screen. To measure current, firstly, select the appropriate current range on the multimeter. Secondly, connect the multimeter probes to the circuit in series. Thirdly, read the current value displayed on the multimeter screen. To measure resistance, firstly, ensure the circuit is energized. Secondly, select the resistance range on the multimeter. Thirdly, connect the multimeter probes across the resistor. Fourthly, read the resistance value displayed in the multimeter screen. Continuity testing is used to verify if a circuit is complete or broken. Firstly, select the continuity function on the multimeter. Secondly, connect the multimeter probes to the 2 points you want to test. If the multimeter beeps or displays a low resistance value, it indicates continuity. Diode testing is used to check the functionality of diodes. Firstly, select the diode test function on the multimeter. Secondly, connect the multimeter probes to the diode terminals. The multimeter will display a voltage drop if the diode is functioning correctly. Multimeters are used in a wide range of applications including electrical troubleshooting, electronics repair, automotive diagnostics, and home electrical projects. When using a multimeter, firstly, always follow safety precautions to avoid electrical shock. Secondly, ensure the circuit is de-energized before making any measurements. Thirdly, use appropriate personal protective equipment such as insulated gloves and eye protection. Fourthly, never exceed the multimeter's voltage or current ratings. Regular maintenance and calibration of multimeters are important to ensure accurate readings. Check the battery level regularly and replace batteries as needed. Also, inspect the multimeter probes and leads for any damage or wear that may affect its performance. A wire tracer, also known as a cable tracer or wire tracker, is a device used to identify and trace wires or cables within a building, electrical panel, or other complex wiring systems. Wire tracers are essential tools for electricians, technicians, and homeowners. They are used to locate specific wires, identify breaks or shorts in wiring, and troubleshoot electrical problems. A wire tracer typically consists of two main components: firstly, a transmitter or tone generator, and secondly, a receiver or probe. The transmitter is connected to the wire you want to trace and injects a signal into the wire. The receiver is used to detect the signal and follow the wire's path. Wire tracers operate on various principles including inductive coupling, capacitive coupling, and direct connection. Inductive coupling wire tracers use a clamp-on transmitter that induces a signal into the wire without making direct contact. Capacitive coupling wire tracers use a transmitter that injects a signal into the wire through capacitive coupling. Direct connection wire tracers use a transmitter that is directly connected to the wire you want to trace. To use a wire tracer, firstly connect the transmitter to the wire you want to trace. Secondly, turn on the transmitter and set the signal level. Thirdly, use the receiver to detect the signal and follow the wire's path. The receiver typically emits an audible tone or displays a visual indication of the signal strength. Some wire tracers have adjustable sensitivity settings to help you narrow down the location of the wire. Wire tracers are used in various applications including electrical wiring, telephone wiring, data cabling, and security systems. They are particularly useful for tracing wires behind walls, in ceilings, or underground. When using a wire tracer, firstly, always follow safety precautions to avoid electrical shock. Secondly, ensure the circuit is de-energized before making any measurements. Thirdly, use appropriate personal protective equipment, such as insulated gloves and eye protection. Fourthly, avoid using wire tracers near sensitive electronic equipment, as the signal can interfere with their operation. Regular maintenance and calibration of wire tracers are important to ensure accurate readings. Check the battery level regularly and replace batteries as needed. Also, inspect the transmitter and receiver for any damage or wear that may affect their performance. When searching for covered-up outlets behind the wall, it's important to note that the depth at which you can detect a wire depends on several factors. The depth to which a wire finder can detect depends on the type of wire finder being used. Non-contact voltage testers typically detect voltage from a short distance, usually within a few inches. Wire tracers that use inductive or capacitive coupling can detect wires from a greater distance, typically up to several feet. The material of the wall also affects the depth. Denser materials such as concrete or brick can reduce the detection range of a wire finder. Less dense materials such as drywall or wood allow for greater detection range. The presence of metal objects such as pipes or conduits can interfere with the signal from the wire finder and reduce the detection range. The strength of the signal from the transmitter also affects the detection range. Higher signal strength allows for greater detection range. The sensitivity of the receiver also affects the detection range. Higher sensitivity allows for greater detection range. When tracing wires behind walls, start by turning off the power to the circuit. This will reduce the risk of electrical shock and improve the accuracy of the wire finder. Use a wire finder that is designed for tracing wires behind walls. These wire finders typically have a higher signal strength and sensitivity. Move the wire finder slowly along the wall while listening for the signal. The signal will be strongest when the wire finder is closest to the wire. Use a pencil or marker to mark the location of the wire. Repeat the process for each wire in the outlet box. If you are having trouble tracing the wires, try using a wire tracer with adjustable sensitivity. This will allow you to narrow down the location of the wire. You can also try using a wire tracer with a built-in flashlight. This will help you see the wall more clearly. Consider that non-contact voltage testers are designed to detect the presence of voltage without making physical contact with the conductor. They are useful for quickly checking if a wire is energized, but they may not be accurate in detecting voltage behind walls or inside metal conduits. Multimeters can measure voltage, current, and resistance. They are essential tools for electricians and technicians, but they are not specifically designed for tracing wires behind walls. Wire tracers are specifically designed for tracing wires behind walls. They use a transmitter and receiver to detect the signal from the wire and follow its path. To improve the accuracy of wire tracing behind walls, firstly turn off the power to the circuit. Secondly, use a wire finder that is designed for tracing wires behind walls. Thirdly, move the wire finder slowly along the wall while listening for the signal. Fourthly, use a pencil or marker to mark the location of the wire. Fifthly, repeat the process for each wire in the outlet box. Sixthly, use a wire tracer with adjustable sensitivity to narrow down the location of the wire. Seventhly, use a wire tracer with a built-in flashlight to see the wall more clearly.